Hey everyone, I hope you managed okay with the activities that we went over in the last lecture. In this one, we're going to go through and explain all of the solutions to these questions. So let's go ahead and move over into Jupyter Notebook. Okay, so here I am inside of our notebook file. The first thing that we'll need to do is import our libraries, which were NumPy, Pandas, Matplotlib, and Seaborn. So I'll say import NumPy as NP, Pandas as PD, Matplotlib.pyplot as PLT, and Seaborn just as SNS. And below this, I'll also set Matplotlib to be inline. Okay, nice one. Next, we have to import our dataset, which is called Chicago_crime_CSV, and then assign that data to a data frame called df. So df is equal to pd.readCSV, and then I'll pass in the name of our dataset like so. Then we wanted to check the head of this, so df.head, and then this will give us a good overview of the dataset with the data for our first 5 rows. We then had a couple more questions on just getting an overview of the dataset. So checking the info, which we could have done with the info method. We can see there's a total of 250,979 rows in this dataset. So it's a pretty large one with 22 different columns, which we can see here. We also get the non-null count and data type of our columns too. Object is the most common data type in this dataset, with a total of 10 columns, and then 5 integers, 5 floats, and 2 Boolean columns. To generate descriptive statistics about this dataset, we could have used the describe method, which would create descriptive statistics for each of the numerical columns in the dataset, which, if we count these, should be 10. As we saw from the info, that we had 5 columns with an integer data type and 5 floats. And then we just had a question on checking the data types, which we did get when we checked the info. But if we only wanted to look at the data types and not any of the other fields, such as the non-null count, then we could just call dtypes on our data frame, like so. Okay, next up, we had our questions on data cleaning and preparation. The first thing that we needed to do was see how many missing values we have in our dataset, which we could have done with a combination of .isNA and .sum. In this dataset, we can see that we've got 1,139 missing rows in our location description column, and then 35 in our X and Y coordinates columns, as well as our latitude, longitude, and location. Compared to the overall size of the dataset, there's not too much missing data here, but in this case, it wouldn't make sense to fill these values, as the recorded location of each crime is very specific, and calculating the average of the location wouldn't be all that helpful, and actually potentially be a detriment to our analysis. So instead of filling them, we'll drop these missing values instead. The method for this is drop_NA, which will call on our data frame, and then I'll set this to be in place. Let's check the sum of our isNA. isNA again. Perfect. So we've now no longer got any blanks or missing data in our dataset. Then we have to change the dtype of our date column to actually be datetime and not an object as it is currently. This isn't something that we've covered so far, so you might have needed to use Google to do this. And if you did, that's completely fine. I'll first select the date column from our data frame and then apply the pd.toDateTime function in order to convert it to a date-time format. And basically, all this does is take the date column from our data frame, convert its data type to be date-time using this function, and then we assign the result of this operation back to our data frame. I'll just quickly pull up the docstring for this function, and as we can see from its description, it just converts a scalar such as any of these examples here and converts it into a pandas datetime object. And let's just check the output of this column, and that's perfect. Our next data cleaning task was actually to add in some new columns which were actually related to the date column that we just converted. Like I mentioned before, this process is typically referred to as feature engineering or feature creation, which is normally referred to in the context of machine learning, but it also has a place in the data cleaning process too, as it can allow us to create new ways to analyze our data. In this case, I'd like to create 3 new columns to extract the month, hour, and day of week for each recorded crime in our dataset. Starting with the month column, we'll say df and then index our data frame at the month column, which currently doesn't exist, and we'll say that this is equal to our df date column. To extract the month from this, we'll use some new code that we've not yet covered, which is the dt.month attribute. dt is what allows us to access the date-time properties of our column, and then .month is the attribute that we access from the .dt accessor, which just of course extracts the month of the column. So let's now just check the head just to make sure that this has worked. And this looks to be fine here. So the month in our date column and our new month column match for each of these rows. So this all looks fine. I'm now going to fast forward and repeat the same process, but for our hour and day of week columns. But instead of using .dt.month, I'll use the dt.hour and dt.dayofweek attributes respectively. Okay, nice one. Then we needed to use this dictionary to map the day of week numbers to their corresponding names, where 0 is Monday and 6 is Sunday. And just to clarify this, the dt.dayofweek attribute sets Monday to be equal to 0 and Sunday to be equal to 6. So that's where these numbers have come from. To do this, we can apply the same process that we used in section 16 for our Python data cleaning example. More specifically, we'll say that our df day of week column is equal to this column again, but then on this, we'll call the map method and pass in our day of week dictionary map that we have here. All we have to do then was drop any unneeded columns, which in this case was the updated on column, which I'll do here. And as we're operating on columns, we'll also need to set an axis of 1. And for the last data cleaning activity, I'll just check for any duplicates by indexing our data frame using the df.duplicated method. Okay, great job there. With our data cleaned, we're now ready to move on to analyzing and visualizing our data. We start out by answering a couple of key questions, such as which districts have the most reported crimes, which months of the year also have the most reported crimes, and so on. For our first question, we need to select the district column from our data frame, and then call the value counts method on this in order to return the count of rows for each district. By default, this method returns the list in descending order. So to get the 5 districts with the most reported crimes, all we need to do is look at the head of this, which by default returns the first 5 rows. And then for the top 3 months for crime, we could reuse the same code, but changing our column to the month, and then our head to return only the top 3 rows. To view the number of unique locations from our block column, we would need to use the nUnique method, which counts the number of distinct values in a specified series or data frame. Each column in a data frame is just a series. So if we call it on our block column, then this would just count the number of unique values in this column, which we can see from this that we had 28,375 unique blocks. And then from our column definitions up here at the top, we can see that a block is just the partially redacted address of where the incident occurred. To compare this to the total number of crimes reported, we could just have a look at the total count of this column, which comes out at 249,802. Or alternatively, we could also just check the length of the data frame too. Next up, we wanted to find out which were the most common types of crime in Chicago. To do this, I'll reuse the same code from above, but this time checking our primary type column instead. We can see from this that the most common type of crime is theft, with 54,000 of all of the reported crimes in this dataset coming in as this type. And this is then followed by battery, criminal damage, motor vehicle theft, and then assault coming in last with just under 22,000 reports of this type. Instead of just having this as a pandas series, as it is currently, it would be better to put this data onto a plot so that we can see this information visually. As we're just counting values, I'll go ahead and create a count plot, but this time, instead of plotting our values onto the x-axis and creating a column chart, I'll actually plot them on our y-axis and create a bar chart. The data will be our DF data frame, and then I'll also set a palette of Viridis. If we run this as it is though, that will plot the count of every single category, as well as plotting them in a random order, which we can see here makes our chart way too busy and cluttered to be effective. To get around both of these issues, we could set the order argument on our count plot. Let's create a new variable, which I'll call order, and then I'll copy down this code that we created here, which just provided us with the top 5 types of crime. Finally, we'll need to select the index from this, as without it, our order variable would be a series which contains both the crime types and their counts. But our count plot will expect the order to only contain category names, and not any values in the form of a series or data frame. So by setting index, we're just extracting the category names from the series, and this then tells the count plot to display these categories. So basically, all this order is doing is telling our count plot to display these categories in the specified order on the y-axis. And if we run this now, we'll get our plot which matches the example perfectly. I'll just finish this chart off by adding in our axis labels and title. Perfect. Okay, next up we had a collection of questions on the temporal analysis of crime distribution within our dataset. In case you're wondering what this means, temporal refers to time. So this basically just means that we're examining how crime patterns change over time. This is a term that you might come across in some of your data analysis roles and jobs, so I wanted to include it just to make you aware of what it means. Before we can create any of our plots, we'll need to create a group by object that groups all of our data by month and then count the number of crimes in each month. I'll say count by month is equal to df.groupby and then our month column. As we need to count the number of rows, so basically how many crimes were reported in that month, I'll set the size method. As well, I'll also call reset index, because as we can see from the example here, our row labels are separate from our month numbers, as our row label starts at 0 and our month starts at 1. If we didn't specify this, our row label would actually be set to the month number, and the values would just be the count of crimes, like we can see here. And the issue with this is that it would make our data much harder to visualize, as our months wouldn't be seen as part of the data because they'd be set to the row labels. Finally, I'll just show you one more trick when grouping, and that is the name argument. If we want to rename the column for our group data to something a little more descriptive and meaningful, we could say that name is equal to, and then put in the name of what we want to call our column, which in this case, I'll just call crime count. And that will then set this column name to crime count. We've now got our grouped data showing the count of crime for each month. So let's go ahead and plot this. As this is showing a change in data over time, I think a line chart would be a good option to visualize this. So I'll call the sns.lineplot function and set all of our arguments with the month on the x-axis, the crime count column on the y-axis, and then the data will be the count by month variable that we just made. I'll also quickly set a marker of O as well as our title. My mistake. I accidentally closed the brackets for our line plot twice. I'll just go ahead and remove this, and then that will sort our error. We can see from this that crime started off pretty high in January and then fell off slightly in February. From then, the level of crime had been steadily increasing up to around the middle of the year where it peaked, before decreasing slightly going into September and October. The number of reported crimes for December then drops massively by around half. But this is actually because the data for this month was incomplete. So we only got around half a month's worth of data for December, which explains why there's such a large drop here. Next, we had to create a count plot to show crime by day, but then broken down or split by the domestic column. I provided you with a list here so that we can set the correct order for our days. I'll call sns.countplot, set our x-axis as the day of week column, the data as df, our order as this list here, and finally, to split the results of this by the domestic column, I'll set the hue argument too. But if we were to run this as it is, we'll actually get an error, as we can see here. This error is caused by the hue argument that we set. The domestic column, as we saw before, has a Boolean data type. Seaborn count plots don't directly support Boolean values for the hue argument, which, as mentioned, our domestic column does have. What we'll do to fix this is modify the code to convert the Boolean values in the domestic column to strings, and we'll do this using the asType method. Looking at this, there aren't really any days that we could class as outliers with a massively higher or lower number of crimes, but we can see that Wednesday dips slightly, with Friday peaking with the highest number of non-domestic crimes. Interestingly, Sunday has the highest number of domestic crimes, which does make sense, because of course that's when people are at home for the weekend and not out at work and so on. Our final plot for this set of questions on the temporal analysis was a histogram to look at which hour has the most reported crimes. And this was quite an easy one. I'll call the sns.histplot function, set our data, and then our x-axis will be the hour column. Another important change that I'll also make is going to be to set the number of bins to 24. And the reason for this is that there's 24 hours in a day, so we'd like 24 different bins, with one for each hour. Finally, I'll also set our chart title too. Midnight has by far the highest number of crimes reported out of any hour, which again makes sense, as this will be when most people are out drinking alcohol. This number then falls off pretty substantially in the early hours of the morning, falling to its lowest value at 5 AM when everyone will be in bed. And then it rises as the day goes on, peaking again at around midday before slowly decreasing. That's it for our time-based analysis questions. There's so many more different topics that we could have looked at and explored here, such as what the most common types of crime are early in the morning, at around midnight to 1 AM, and then compare this to the most common types of crime at midday to see if there's any difference between the two. For your own learning, I would really encourage you to come up with some of your own questions and then try and answer them. If you have a good question that you can answer, then please post it down in the Q&A section below, and I'll walk through how you could answer it with you. The final topic of analysis for this notebook was on arrest and domestic incidents, just to see how many of the reported crimes were a domestic incident or resulted in an arrest. All of these plots would just have needed a count plot, so hopefully they should have been fairly straightforward to create. Our count plot for showing arrests versus non-arrests would just have needed the arrest column on our x-axis, our df data frame as the data, and then I also set a palette of Viridis, but this would have been an optional step. Clearly, there were a lot more crimes where the perpetrator wasn't arrested, so we could infer from this that either the crimes committed aren't that serious, or that they got away. But more likely, the true answer to this will lie somewhere in the middle of these two options. For our next count plot, we could have just reused this code, but setting the x-axis as our domestic column instead. Again here, there were a lot more non-domestic crimes than domestic crimes, with around 200,000 non-domestic and 50,000 domestic crimes. But of course, these numbers are both still way too high, so this is some good data and information that we could pass on to our managers. The very last plot that we create here is another count plot to have a look at the number of arrests for each type of crime. I'm going to start out by increasing the figure size as I know that there's quite a lot of different crime types, so I'd like a little more space for our plot. The plot itself will be very simple, with just a count plot with our primary type on the x-axis and our data frame as the data. Currently, our axis labels are a bit of a mess, so I'm going to fast forward while I add in our chart title, axis labels, and then just our x-axis labels. Alright, and that looks much better. You might notice though that we also get all of our different X labels printed out above our graph. Whenever we adjust our tick labels like we've done here, then our labels will also get displayed. Personally, I really dislike this as I find it makes our plot and charts quite messy. A really helpful little trick that we can do to stop this from happening is to put a semicolon just after our X ticks argument, like so. And if we run this again, then all of our labels from up at the top have gone. As mentioned, there are quite a lot of types on our plot here, so something that we could do is plot only the top 10 most frequent crime types to make our chart a little neater. There's a couple of ways that we could go about doing this, so use Google and reference what we've learned so far to see if you can figure out how you'd go about making this change. If you manage to find a solution, then feel free to share it down below, or alternatively, if you're stuck, then of course post any questions that you might have down in the Q&A section, and I'll get back to you. Okay, that wraps it up there for this section. I hope you've enjoyed it and you found it useful. You've also now got another complete portfolio project that you can share with any employers as part of your CV. As I mentioned at the start of this section, there's another complete project within the section folder, which is on Glassdoor salary data, which you can find from within the Glassdoor folder. It contains a load of recommended questions, along with the answers in a separate notebook file, and then of course the data file too. And then that'll be yet another complete portfolio project that you can work through. In the next section, we're going to have an introduction and overview of machine learning in Python, where we'll use the scikit-learn library to predict the survival rates of passengers that were on board the Titanic based on some different factors such as their age, cabin class, and so on. If you've got any questions at all from so far, then please post them down in the Q&A section below. Thanks everyone, and I'll see you all back in the next section.